I'm going to demonstrate how to use an interactive simulation that models the temperature mole fraction diagram for two immiscible liquids, and so the phase behavior when we have liquids and vapor present. The simulation is located at this link on the LearnChemE site, and this is a snapshot of what the simulation looks like. We can move this black dot around by changing the mole fraction of benzene and by changing the heat added or removed. We can also change the diagram by changing the pressure, since the TXY diagram is for one pressure. The simulation shows then the phase envelopes, where at higher temperatures we have vapor, at the lower temperatures we have two liquids, and then we have regions where we have, in this case, liquid water plus vapor, vapor containing both components, or liquid benzene plus vapor. The bar graph on the right represents the height of the bar, represents how much of each phase we have, where we have a total of 1 mole, liquid water, liquid benzene, and the vapor, and then the mole fraction of vapor is given. So for this particular condition where the dot is here, this is the mole fraction of vapor, which is this dashed red line. So let's look at this interactive simulation to understand behavior as we move this black dot around. So I point out that over here we have some directions on how to use the simulation and some details of the equations that were used to generate it. And if I change the pressure, then you'll see the values change for saturation temperature. So here at pure water, this is the saturation temperature at this pressure. So let's look at an intermediate value. Now, if I add heat to the starting point here, which is a mixture of water and benzene, a mole fraction of 0.5, I can move that around. And of course, we only have these two phases, so 0.6 mole fraction benzene would mean for total 1 mole, we have 0.6 of a mole of benzene, 0.4 of a mole of water. So let's look at what happens if we add heat. Well, nothing changes till we get to this temperature. And this is the one temperature for this pressure where 3 phases coexist: liquid water, liquid benzene, and a vapor that contains both. This is the mole fraction, 0.55, of benzene in the vapor phase, corresponding to this red line. If we're anywhere on this temperature line, the vapor that's present has this mole fraction of 0.55. As I add heat now, the temperature doesn't change, but we get more vapor and less liquid. And we'll keep adding heat until all the liquid benzene disappears. Now we have liquid water and 2 components in the vapor phase. And now as I add heat, we're raising the temperature, evaporating the water until we get to vapor phase. We have all vapor, and we have the same, of course, mole fraction that we set, the overall benzene mole fraction, 0.38. Reset condition just takes us back to the beginning. If we're over to the right and I add heat, then we'll see that the water has a lower total amount in the mixture, evaporates first at this temperature, and then we raise the temperature, we start evaporating the benzene. So hopefully this simulation allows you to better understand the behavior when we have 2 immiscible liquids and a vapor phase above them.